We are in the first block of the foundation program dealing with whole numbers. Our topic is place value and ordering. In the first topic, we looked into how words are formed and used for writing numbers given in the digit form. There, we didn't look into the value represented by the individual digit of the given number. In this topic, we will be looking into that aspect, meaning the values represented by the individual digits of a given number. In the first topic, I have mentioned that consecutive numbers in one digit are introduced with a gap of 1 unit. Further, I mentioned that 0 is nothing, so it is not considered as a number. When you keep 0 in front of any other digit, the value of the digit or the name of the digit does not change. Those things I have mentioned. And further, I mentioned that when you keep 0 after a particular digit, then we have a different name for that number. In this case, it is 10. Now, we will look at in a different angle how this is taking place. The number after 9 is 10. The number after 9 is 10. Now, if you take this number 10, since 0 is nothing, the full value of 10 should be represented by this digit 1. The full value of this 10 should be represented by this digit 1. Now, let us say represents this digit 1 represents 10, which means the value of this digit 1 in this position should be 10. So, if you take this number card and show it to somebody in isolation, it is representing 1. But if you keep number 0 after number 1 and show it to somebody, and then that digit 1 should represent 10. If I put it differently, though the face value of digit 1 is 1, the place value, the value represented by that digit according to the position, in this case is 10. I hope that you understood it. Alright. So, let us take another example, random example. Think about this 16. Let us say that there are two number cards. Okay. So, 6 is representing 6. So, digit 1 here should be representing 10. The place value of 1 is 10. We identify the digit onto the extreme right, as the digit carrying unit values, that is carrying unit values. And then the second digit from your right, we identify them as tens. Check another example. Now look, this 20, 0 represents nothing, so 2 should be carrying the full value of 20. So, the 2 here represents 20. If you think about this, 24, 4 is representing 4, 2 is in tens. Okay, so it should be representing 20. Consider this number 100. The two zeros are representing nothing. If it is so, the digit 1 here should represent 100, which means the place value of 1 in this case is 100. Take another example. Take this. This 892, 2 is in the unit position, so it should be representing 10. 9 is in tens, so it should be representing 90, and 8 is in hundreds, so it should be representing 800. Take this number. 4 is in unit positions representing 4. This one is in tens representing 10, and the other one is in hundreds representing 100. Though it is the same digit, the place value differs depending on where it appears. Now take this number, look, 6 is in unit positions representing 6, 5 is in tens representing 50, 4 is in hundreds representing 400. 3 is in thousands position, so it keeps on increasing, so it should be representing 3000. And 2 is in 10,000 position, it's in 10,000s, so digit 2 here should be representing 20,000. As a general rule, look, when there are more number of digits, the value is definitely higher. Now in your next page, this is being explained, and then I have given a separate number. Write down the place values of all the digits in the given number. So let's do that. Let's do it together. This is the knowledge assignment. So let's activities, we will do it together. Yes. So the 6 is in the unit position representing 6. 8 is in tens representing 80. 1 is in hundreds position representing 100. 7 is in thousands position, so must be representing 7000. And this 0 is nothing. Wherever it appears, it is nothing. Though it is in 10,000 positions, nothing in 10,000 positions, so it is 0. And then this 5 in 100,000 positions, so it must be representing 500,000. 4 is in the position of millions, so that digit 4 should be representing 4 million. Okay, get it entered in a similar manner. All right, that is the concept of place values. We will now look into how to do the ordering of numbers. This is said to be the greater than sign. This is the greater than sign, and this is said to be the less than sign. In the greater than sign, what will happen? The number onto your left, the number onto the left of the sign is greater than the number onto the right of the sign. And here, number onto the left of the sign is less than the number onto the right of the sign, which means I can give a different interpretation. Now think about this open end. The open end is always towards the bigger number. The open end is always towards the bigger number. Check the question. Insert the proper sign for ordering the following numbers. We'll do it together. Yes. Right. Okay. Now apply the basics. You need to do two things. First, check for the number of digits. If the two numbers are having different digits, obviously the number having a higher number of digits is the bigger number. Now here, the left hand side you have 6 digits, right hand side you have 5 digits. Any number having 6 digits is greater than any number having 5 digits. No more checks are needed. So your left hand side is bigger. Open end of the sign should be towards the left hand side. Okay, fine. Let's go to the next number. Two numbers are there, and then both of them are having 6-digit numbers. So my first check won't be successful, so I have to go to my second check. You need to go to the place values. So the first digit is obviously is having a higher place value. So it is 8 on my right hand side, it is 7 on my left hand side. It is not necessary to look into the place values of any other digits. Look into the place value of the highest digit. My right hand side is bigger, so the open end should be towards my right hand side. Yes. In this tutorial, rather than inserting the sign, you can enter the other signs that I am giving, my working signs as well. So that will give you where to make the decision. Yes, take this one. Let's apply. No point of looking into the number of digits, both are having 6. Then you need to look into the highest place value. Highest place value is the first digit in each number. But this highest place value 6 is common to both numbers, so that won't help me in making a decision. Next you have to go to the next highest. Next highest in this case is the 10,000 positions. So 10,000 positions are also the same. So that won't help me. And go to the next highest, that is the 1000 positions. 1000 positions are also the same, that won't help me. Right? So go to the next position. Next position is hundreds. Hundreds, it's 1 on my right hand side, it is 0 on my left hand side. So 1 is bigger than 0. No need to look into the other digits. So your right hand side is bigger, open end with the right hand side. Okay. Next number. Take this. First check number of digits. I can see 7 digits on either side, and then we will make an improvement to our approach. Look at them carefully. The first 4 digits are the same on either side. The first 4 digits are the same on either side, but when we cut off, we will cut off on block basis. So 2 won't make any difference, and the next middle block 007 is common. So that won't help me in making a decision. So then what will help me in making a decision is the position of hundreds. So in hundreds you get 9 on the left hand side, you get 6 on the right hand side. So I am not looking into the other digits. So my left hand side is bigger, open end towards my left hand side. Yes. Right. And then take the next one. 9 digit numbers. First 3 digits very clear, we'll go by block basis. And then if you look into the next block, the middle block, first 2 digits are the same. So I am left out to make a decision on the position of thousands. My right hand side it's 5, so it's 5000 something, and then on my left hand side it is 0. So quite obviously my right hand side is bigger, open end to the right hand side. Take this. This is the last individual set. Yes. Both are 9 digits. Look, there's a difference in the first block itself. So then only 2 digits are the same. Only 2 digits are the same. So I am making a decision on the position of millions. It is 3 on the right hand side, 0 on the left hand side. So my right hand side is bigger. Okay. Now let's go to the next question. Arrange in the ascending order. Arrange in the ascending order. Ascending order is you have to write the smallest number first, and the numbers are progressively bigger. So you have to pick the smallest number. Now pause the video and make a try. Apply the principles. Seemingly they are having different digits, so it's easy if I write down the digits on top of each number because there are more than 2. So this is having 5 digits, 4 digits, 6 digits and 5. Okay, let's look at how we can order more than 2 numbers. We need to arrange in the ascending order. Ascending order means smallest number first and the biggest number the last. I am first looking at the number of digits. Write it with me. I am writing the number of digits in each number. It's 5 here, 4 here, 6 here, 5 here. Alright. So you can decide what the smallest number is. That is this one. So on top of it, say first. That is the first number I should write. Then I have 2 5-digit numbers where the first digit is the same. I can compare this 5 and 4. I want the smallest first. So this should be my second. Mark it. This should be my second. And then this should be my third. So if it is so, the highest number should be the number having 6 digits. That should be my fourth. Now it's a matter of writing them. And even when I write them, I don't read it 6, 2, 3, 4. I am just reading the digits only. Then I have to write 6, 4, 3 zeros. And this is the sign. Open end towards the bigger number, towards my right hand side. And then 6, 5, 7, 4, 9. Yes, and then finally 6, 0, 6, 7, 5, 6. That's it. Yes, let's try to do this together. This should be in the descending order. Descending order means the biggest number first. Pause the video again. I hope you can do this on your own. So let's look at the number of digits. Write it down at the bottom of the number. 5 here, 5 here, 4 here, 5 here. There are 3 numbers having 5 digits. So we know the smallest number quite directly. So the smallest number should come last. So look, I can just write 4th here. This is what I can directly see. So I can enter it. And then if you think about the other 3 numbers, first digit is the same. Look, the second digit is also the same. So I can compare 9, 8 and 7 and make a decision. So the biggest number, I am looking at the biggest number. So 9 here is the biggest number. So my rightmost number is the first number that I should write. And then it is 8 second, and then it is 7 third. So that should be the order of the numbers. So write them. 99 900 and then 99 800. So now this is the sign. Open end towards my left hand side. And then 99 765 and finally 9100. Not necessary to read the numbers in full. Apply the rule. Okay. You can retry the activity we have just done in a separate attempt at your own pace. You can also revisit the video for added confidence once it is reattempted. Our next step is to look into the same topic in the application level.
Ten. 9. 8. 7. 6. 5. 6. 4. 3. 2. 1.